Hello and welcome to yet another WJEC A level physics question. This one was from May 2010's Unit 1 and it was question 5 on the paper, and it's basically about EMFs and internal resistances. So what we start with is basically a standard formula given in the data book that V equals E minus IR. Here V is the terminal PD, which is basically the amount of electrical energy that's transferred per unit charge to the external circuit for that external circuit to turn into other forms. We're asked to fill in terms of energy what the meanings of E and IR are. So E is the EMF, and there's not a lot of room to write a sort of really full definition here, so let's put it down very briefly. The EMF is the amount of chemical energy converted to electrical energy per unit charge. We mustn't forget that per unit charge bit, passing through the cell. Now I times R is sometimes known as the lost volts, but in terms of energy, it's the amount of electrical energy that's turned into heat energy, again per unit charge. In the internal resistance. Next, we're told that a torch battery transfers 4,750 joules of chemical energy into electrical energy while supplying a current of 0.22 amps for 1 hour or 3,600 seconds. And it delivers 4,500 joules of energy to the bulb. We've got to calculate the charge that flows. Well, we can use the current formula. Current is charge over time because current is rate of flow of charge. And that will allow us to see that the charge is equal to the current times the time. So we've got a current of 0.22, the time has to be in seconds, not hours, and that will give us 792 coulombs. To find the EMF of the battery, we just need to remember that the definition of the EMF is the amount of chemical energy that gets converted to electrical energy per unit charge. So here, 4,750 joules of energy was converted into electrical energy from chemical energy when that 792 coulombs of charge passed through the battery. So if we do 4750 divided by the 792, we get 5.997, so we just call that 6.0 volts for the moment. But I'm going to store that answer in a memory so that I can get the exact answer back a little bit later on. Now similarly, the definition of the PD across the bulb was the amount of energy that was converted from electrical energy to other forms, heat and light energy, by the bulb, or the amount of energy that was transferred to the bulb by the circuit. So here we're going to take the 4,500 joules that was delivered to the bulb and divide it by the same 792 coulombs of charge. That will give us an answer of 5.68, so just call that 5.7 for the moment. For the next part of the question, we're asked to find the PD across the internal resistance, or the lost volts. So basically what we've got is that this is 5.7 volts, this is 6 volts, so the IR term, which I mentioned earlier, is called the lost volts. It's just the difference between them. So what we're going to say is I times R is 6.0, take away 5.7. And the reason why I stored the number in memory is that if we just do that calculation as it stands, it looks as if the difference is simply 0.3 volts. But what we've got here, let's just do this on the calculator. We end up with a difference of 0.3157 and so on. So let's going to call it 0.32 volts. So basically we're gaining an extra significant figure here by saving the value of the EMF in a memory. To find the battery's internal resistance for the last part of the question, well, I times R was 0.32 volts. So the internal resistance is going to be that 0.32 divided by the current, which was 0.22, and again using the answer button on the calculator, we end up with that internal resistance as being about 1.43 ohms, so let's just call it 1.4 ohms. So thank you very much for listening. Please remember to like and subscribe and add some comments at the bottom of the video. Thank you.